Good morning, everyone. Thanks for joining us. My name is Milan Patel, and I'm accompanied here today with Vivek Shankar, who's the product architect for IBM Security Verify. And my role is the product manager with IBM Security Verify. In today's session, we're going to be talking about a pretty hot topic, open banking and high assurance identity, and how IBM Security Verify is poised and enabled to help organizations on the journey for implementing and leveraging the most current standards, as well as the most secure posture in implementing single sign-on federation, consent, multi-factor authentication, and risk-based authentication. This also includes passwordless as well. So as we get started, please use the chat, ask questions. We'll answer the questions as we go, and then we'll also spend maybe 15 minutes at the end aggregating all the questions and answering any leftover questions that we have throughout the presentation. Again, thanks for joining us, and we're happy that you're able to spend this morning, afternoon, and evening with us. Okay, so let's get started. So what is open banking, and what's an open banking scenario? Well, in the US, a lot of us use Venmo or Zelle or any other fintech type of solution that allows us to exchange money peer-to-peer, right? But when you think about that, there's really three personas involved. There's the user, there's Venmo or Zelle or the fintech solution, and then your bank, in which the transaction needs to be facilitated across the different entities. Now, at the end of the day, what the user's doing is the user's creating an account with Venmo, then basically federating and authorizing their bank to release some information to Venmo so Venmo can do the transactions, right? So not only does the user have an account with Venmo, the user then needs to perform authorization and sign on to the bank to provide some level of consent and authorization associated with what the bank can release to Venmo. And that entire activity needs to be captured in a central place as part of consent, but also authorization requests. Now, when we think about this, identity is the core to open banking flows. And there's three reasons why. The first is authorization and sharing of PII, right? So the user will need to be able to share bank account information, address, name, and other things that are needed to facilitate the transactions between Venmo and the bank that the user permissions. The next thing is consent. So as part of interacting and performing this transaction, a user consent needs to be captured, but also logged for future reference in case there's a dispute. And part of that is being able to have a unique consent ID. And Vivek's going to talk about this in detail, right? But here is really just laying down the scenario. And then the last thing is just full transparency. So, as a user, I should be able to go into my bank account and my profile and see what all I have authorized the bank to release on my behalf to other applications. As I go into Venmo, I should be able to see what information Venmo has about me related to the apps that I've authorized it to have access to. So you can see the directional visibility that a user may need related to this open banking scenario. Now, going a little bit deeper into a typical end user flow. So as we see this, the user enters credit card information, it goes through a payment process, and as part of that payment process, they get a push notification to their mobile device. That push notification may say, "Hey, you are making this payment on behalf of you as the user, and you need to authorize certain clip levels and certain details associated with the transaction." And this could be done again via push mobile notification. And in that push mobile notification, the user responds back with, "I authorize X dollars for this specific use or this entity, and here's the reference number that could be associated with it," right? So three key things happen here. Authorization is performed. either through a native login or a social login. An authorization policy is defined. This could be how a user authenticates and what is required to perform authentication. And then the last thing is a consent statement is recorded and referenced with the specific details of the consent profile. This, again, in a holistic level, needs to be considered and is a critical component to what it means to have an open banking and an open model associated with how these interactions are captured, but also how consent is captured. Now, when we think about this in the context of what is the solution now in market that can help me enable this? Well, this is where we come in with IBM Security Verify, right? So our mission related to IBM Security Verify is being able to see how we can securely connect any identity to any resource. So this includes things like single sign-on, a directory, multi-factor authentication, risk-based authentication. So if you think about the experience that we just showed, let's say a user tries to perform a transaction and the clip level is $1,000. Well, that could trigger a continuous risk-based assessment and trigger a step up, right, based on the clip level of money being exchanged. So this is the type of flexibility that is needed in the context of the solution and how Verify SaaS can provide that value. The other things when we think about banking use cases, passwordless and FIDO, which now the term FIDO is changed to passkeys. So that's native support in our Verify SaaS platform. And then we talk about maybe a little bit adjacent use cases around governance and lifecycle management and data privacy and consent. So Verify is that single solution to be able to help protect workforce identities, which is maybe employees of financial institutions. But really what we're focused on this talk is around consumer identities, which is folks that are banking with financial institutions and that may use fintech solutions to help facilitate easier experiences, as described in the Venmo scenario. The key thing here and what we really drive towards is we know customers are adopting a hybrid cloud strategy, and being able to protect apps through a central framework, which is IBM Security Verify, with applications running across any cloud, the resources being any type, whether they're mobile, web, databases, servers, operating systems, and being that single enforcement point to centralize authentication, authorization, multi-factor risk-based authentication, and privacy and consent through the single experience. Now, when we think about IBM Security Verify, it's offered in varying forms. And what we're going to be showing here in the demos and in the conversations is really focused on our IBM Security Verify SaaS solution, which is a identity as a service that brings together governance, consumer, and workforce access management into a single platform. But we also offer on-prem deployments with IBM Security Verify Access, and from a governance standpoint, IBM Security Verify Governance. So our core proposition here is an IAM stack that can run either on-prem as software or in the cloud as a SaaS, with a converged set of experiences to be able to deliver workforce, consumer, and governance through a single solution. Now, specifically to our SaaS product, our SaaS is deployed in 6 regions in terms of general availability, and we're also have a government-ready environment in the US. So the regions are the US, Europe, China, Japan, Canada, and Australia. And we run at a 99.99% SLA. The other thing that's critical is compliance and certifications. So the SaaS platform is compliant to PCI, SOC 2, Type 2 and 3, ISO certified. And again, although this talk is specifically for open banking, high identity assurance can also be applied to other verticals like healthcare. And this is where things like the HIPAA certificate, HIPAA readiness align to how these federation and login and consent flows applied using the open banking standard can be leveraged for higher level assurance across different industries. And then you can also see our certifications related to the open banking profiles. More to come on that in the later slides. But you can see our SaaS platform is primed not only from geographic diversity, but also robustness in the compliance and certifications that we offer as part of the solution that we deliver to market. So with that, I'm going to hand it over to Vivek to talk about some of the specifics related to the open banking needs and drivers.
Yeah. Hi, everybody. My name is Vivek Shankar, and I'm the Chief Product Architect for Verify as a Service. So in this next segment, I'll be taking us through sort of reiterating what Milind covered about open banking and their needs and drivers, and then moving into the different parties involved and how it benefits them. And then we look at a very quick blueprint followed by a demo. So let's kick off. First and foremost, what is open banking? Milind covered this a little bit. At the end of the day, these are a set of rules and procedures to share sensitive consumer data, processes and applications and services with third-party applications. So the focus is more towards delivering additional, possibly niche services that a traditional bank wouldn't offer. And in a sense, in the past, you had silos around traditional banking. As the world evolved, as the digital footprint grew, customers demand more. And so banks provide open APIs that facilitate the exchange of these data, of these processes and apps to an ecosystem of developers and vendors. And let's take a couple of examples of what we're thinking of here. So think of a credit bureau. A credit bureau, for example, Yodlee. It aggregates credit card and loan information from a variety of different sources as authorized by a user who's generally a customer of these traditional banks and financial institutions. And once they've provided that information, it provides those users a credit rating. It may also allow them to share that information with other financial institutions, for example. So there is a data exchange that happens that allows them to make use of a very specialized service. Another example is a personal finance management solution. So consider NIC, for example, which gives users an aggregated view of all of their entire financial footprint. So you know exactly where you're invested, you know what your wealth products are, you know where your accounts are, or what credit cards you own. All of that is combined together and provided in a unified dashboard. And that's another example of a value-added service that a number of users would benefit from. And finally, the most common example would be, and the two examples that I just provided is more around account information, around what's your account balance, your transaction history, and so on. But then when we evolve that into e-commerce applications, that's where it gets even more interesting, and this is something we are all more familiar with, is applications like Amazon, where you perform payments. And to perform those payments, you need to have some sort of a payment API, a gateway that's provided by a bank or by an intermediary that integrates with your bank. And that's how open banking started. And now it's evolved into open finance, which expands the type of services and the type of data that's exchanged to a much wider realm. And we're moving in a direction where data is something that is becoming available to these third-party providers, which makes it extremely important for a end user to be able to authorize the sharing of this data in a very secure manner, in a manner where there is a irrevocable link between the customer's profile and that evidence of that authorization. So in summary, open banking provides a mechanism for all of these, for third-party providers and services to make use of bank-provided open APIs that are hardened and secured based on regulatory and based on standards methods of managing and securing those APIs. it mandates how an application authenticates itself. Consider that this is an application that the bank technically doesn't trust because it's outside of the bank. And so they need to authenticate themselves in a secure manner. It requires user authentication to be tracked, user authorization to be tracked and recorded. And there has to be a mechanism for users to be able to revoke a standing arrangement, for example. So let's say they've signed up for a service, they want to opt out of that service. At that point, the access to that data should be immediately revoked. So FAPI, or Financial API, is the underlying set of regulations and standards that are, and they have a number of working groups in different parts of the world. It started out in the UK with the UK OpenBanking standard, with the Payment Services Directive, and then it has expanded since then into other regions of the world. Now, a couple of benefits around who are the different parties here. You have the financial providers and services. What do they get? They get access to the customer data, which is great because now they can provide a lot of innovative services to these customers, to this demographic of users that previously they would have been hard-pressed to attract. It allows for better collaboration between different financial providers and between different financial institutions. For consumers, it provides a centralized authorization system through which they're able to securely grant access to certain data and to allow their account information to be shared and so on and so forth. It offers, they get to make use of these innovative and niche solutions that are provided by these third-party providers and these financial providers and fintechs and so on. And at the end of the day, it's a delight to use because you now have a number of capabilities that you previously did not. And here's where Verify, and for that matter, Verify Access, which is our dedicated offering, helps here. It standardizes how banks and financial fintechs can securely exchange customer data. We provide a mechanism for native consumer flow, starting from user registration through profile management, so your run-of-the-mill consumer IAMs type journeys, through frictionless authentication experiences, and underlying all of this is a fraud detection and threat analysis engine that protects and secures our customers. There is a strong consumer authentication MFA capability that allows you to use a variety of different factors based on your choice and based on possibly even the regulations of the land. We issue security tokens that can contain fine-grained authorization details and not just coarse-grained authorization, which is what typically you would see with tokens in the past. And all of this is governed and recorded in a data privacy and consent module that contains all of these consents that can subsequently be revoked. So let's take a look at an example of a blueprint. Now, this is just a quick view of a typical deployment architecture. It doesn't mean that this has to be the deployment architecture. This is an example. There are typically three entities. They're the banks, or in different parts of the world, they call different things. For example, in Australia, they call the data holders. You have they make use of IBM Security Verify as their authentication and authorization service, which provides a wide variety of capabilities. It's meant to secure the communication between all of these parties. And you have the third-party provider, which is your data recipient or the AISP or what have you. And those are the applications that are owned by your fintechs that are making use of the open APIs provided by all of these banks. Now, in terms of capabilities that are typically required in an offering of this sort, where IBM Security Verify sits, you have to have strong authentication capabilities, a variety of different authentication capabilities. For example, using social providers, using external identity providers, could be a customer database. It could also make use of passwordless technologies. For example, passkeys, which is an emerging trend. You need to have a strong fraud element. There has to be fraud prevention in the platform, And Verify offers adaptive access, which contains a number of different capabilities around detecting anomalies based on user behavior biometrics. Your keystrokes don't look quite right, or you're accessing the system at the wrong time of the day, and so on. And also information around whether you're coming from a new device altogether. And all of that leads to a stronger consumer authentication experience. In addition to all of this, Verify, the platform itself, offers capabilities around detecting IPs that you're coming in from, managing the, evaluating the reputation of those IPs, and then determining whether or not to let the transaction go past, and so on. So that's IP reputation just being one such example of what we do with our threat analytics engine. In addition to all of this, you have the data privacy and consent management system that allows user authorization to be stored in a manner that's linked to the user profile and is something that can be revoked. It has a shelf life. A consent isn't perpetual, and so a user can actually determine when they would want to recertify, and reauthorize, and so on. And finally, of course, all of this is underpinned with OAuth and OAuth authorization. And that's where it's very important that the system that's offering these capabilities is financial API certified, so as to prove that it has the different capabilities that are required to secure this form of an ecosystem. Going. And now let's get to something that you can see. And we look at a demo with our Verify as a service. By the way, you could do all of this stuff with our Verify Access product as well. But we'll focus today on Verify SaaS. And we'll walk through example. I'll try not to make it too geeky. So we'll have IBM Security Verify playing the role of the authentication engine, the OIDC provider, and so on. You'll have the third-party provider, which is the app on top. And you'll see there is a payment API and et cetera that's hosted by the bank. So that's going to be on and fronted by an API gateway. So let me switch to a screen share. I'm sorry. Yeah. Okay, so I think what you can see now would be a page that says OpenID Connect for OpenBanking. So let's start with what an end user sees, right? So what I've got here is a Node.js application that I'm going to run on my local machine. And this is more to illustrate a payment transaction operation with an e-commerce application. So let's kickstart. And here you see that we have a demo app that where you've imagine that this is your Amazon app or what have you, and you're making a payment transaction. You've completed buying a bunch of things on Amazon, and you're at the point where you want to submit this to make a payment. And so you've chosen the bank that you're going to be performing this payment transaction with, and it will go through the process of authenticating the user. So while all of this is happening, there's a whole bunch of things happening on the right-hand side. So you don't have to pay too much attention there. We'll talk a little bit about that. But as I said, I promise not to make it too geeky, so I won't spend too much time on that. So let's log in with a Google social provider. I could very easily have used the passkey, for example, the FIDO credential, which I have registered on my Mac. But in this case, I'm just going to use a social provider login. And as part of this process, the first thing that you see here is where our adaptive access engine kicks in to evaluate whether or not, what is the level of risk. And if the risk is particularly high, it would have blocked this entire transaction. But in this case, it saw that it's a low risk or a medium risk. And because of the nature of this transaction, it requires a authentication to be completed. So I'm going to make use of the Touch ID that I have on my Mac. And I'm going to complete that verification rather than use a push notification. We could very easily have used a push notification, but I just don't have my mobile phone shared. So we'll use FIDO. And the first thing that you see here, by the way, you can skip this entire screen and you could have made this as part of the push notification, for example. But in this particular case, I'm showing you a consent authorization that the user has to complete, where the amount, the merchant who's performing the transaction, and a reference is defined. And this reference is something that we will see in the token. So I'm just going to go ahead and complete the flow. Now, while you saw all of that, that entire experience can be branded on Verify. So you can have your logos, you can have a completely different user experience if you choose to have that. So let's take a quick look at what is the sort of data that is available. So I mentioned the first thing to notice here is, remember that, as I mentioned before, that this is a OAuth flow. So at the end of the day, it's an OAuth/OIDC flow. And so that's the mechanism through which the application obtains a security token. And that security token has the authorization information that lets them complete the payment transaction. Now, given that they can, so a couple of things that's embedded in here. The first is, this is more UK open banking parlance, where you have this notion of an intent ID, which is effectively a transaction ID. And you see that in the identity token. The second thing that you see here is, so let's take a step back, and I'll just quickly introduce this concept if you're not aware of this. So consider that you go to a particular website and you log in. Now, if you're looking at your developer tools, and this is an application that basically runs with React or any sort of client-side JavaScripting-based framework, you'll see that the token is something that you can grab at any point, the OAuth token or the authorization token, and you can use that token to effectively go and perform operations against a resource API. Now, in this particular case, we enforce the use of mutual TLS. And the reason for that is that allows the transaction to bind the token to a certificate. And that's what you see here as a fingerprint of that certificate. And this is something that when this token's made is used against a payment API, for example, the payment API would be able to validate that this token came from the application to which it was issued and not somebody who grabbed the token, went somewhere else and used it. So this is one of the mandates around the FAPI standards, and one of the reasons why it's important to follow the FAPI standards themselves to have a more hardened system. That doesn't mean that this only applies to banking. It applies to any industry. But in this case, we're specifically talking about banking. Now, there are a couple of questions that have been asked. So I'm going to address them first before we continue. So the first one is, does fine-grained authorization not give a certain unnecessary overhead, and is it still manageable? Well, we've had the notion of our data privacy and consent engine has been around for a fair bit of time, and it's a product of many years of IBM research. And while, yes, fine-grained authorizations can have overhead, but in general, it depends on how it's implemented. So in our case, the way we've designed it and the way it gets used is very similar to how the OAuth rich authorization request standard mandates it. That's one. The second aspect of it is fine-grained authorization is a requirement in many parts of the world. For example, GDPR mandates that you must have a purpose attached to the data that is being shared. For example, if you're sharing an email, it's not enough just to say that I'm sharing the email. You have to inform a user or inform the user who's authorizing that what that email is going to be used for, and that has a legal aspect to it. So it has to be recorded. And so we haven't seen an unnecessary overhead. In fact, I wouldn't say it's unnecessary at all. In fact, this is something that that I see is demanded more and more, given all of the litigation that's happened around privacy, all of the new regulations that are coming in, starting with GDPR way back. And this notion of fine-grained authorization is a key requirement. Now, in the past, people have implemented it in different ways, mostly proprietary methods, using OAuth scopes that have a bunch of metadata embedded and so on, but it's still opaque. It's something that leaves it open to interpretation. What we have attempted to do is to create our consent statements to be fine-grained out of the box so that it's something that already contains the metadata and the information, and it's not something that you can, and we follow the OAuth standards themselves in terms of how it's represented in a token. So I've answered that sufficiently. Just going down. Now, the second question there is, does IBM Verify provide any kind of developer subscription? Absolutely. IBM Security Verify is available as a free trial. It's a fairly generous trial. You get to use, I don't remember the number of users, but it's a large number of users. You can onboard 5 applications and basically get access to the entire system for you to play with. So that's, so I think we might have links. If we don't, we'll share that at the end of the presentation so that you're able to go and pick that up. Okay, just going to keep going. So let's, so we've taken a look at how this looks from an end user perspective, but let's take a moment to look at how all of this fits together from a configuration perspective. So one of the things that we've done with Security Verify is to build a more prescribed experience around best practices and what you should do. This doesn't mean that you can't override it, but we default certain things. So to start with, the product catalog, the application catalog comes with a OpenID Connect for OpenBanking application connector. And it can go through and basically configure what you need. Now, by default, it already has a lot of things preset, so you might not have to do a lot unless you want to override it. So, you know, there's a free trial. Please go ahead and play with it. But you see there are a number of things here. For example, PKCE is enabled by default. This new notion of pushed authorization request is something that's already available as part of the platform. I talked about certificate bound access tokens, the idea of access tokens being tied to a mutual TLS handshake that's between a client and the Verify service. And so that's enforced. So you see a lot of these things are effectively tick boxes that you turn on and you're good to go. In addition to all of this, we also offer what we call recipes. And sorry, let's just go through an authentication real quick. So think of recipes as security profiles. They're effectively security profiles that are based on standards that are out there. And if you take a look at the dynamic client registration section, you'll see that there is a OpenBanking recipe here that lets you choose, for example, UK OpenBanking. There's the FAPI one, advanced final. You'll see the Australia in a couple of weeks and so on. So all of these are the different profiles that we support. And by choosing a recipe and saving that, you're good to go. There's absolutely nothing further for you to do to comply to the regulatory requirements. In addition to all of this, Verify offers a whole slew of reports, and you see these here. And let's zoom into one of them, which we talked about, the fraud prevention component, where we have adaptive access. And you notice here that I have a bunch of low risk transactions, and the reason for that is because I'm accessing from a known and trusted device because I've been using this user account. But if you look further down, there is other information where it says it's a medium risk device because there's been an access with a change in device attributes. So it's not a brand new device, but there have been some changes in the device attributes. And here you see more information around whether this is a risky connection, it's a risky device, whether it's a new device, and so on and so forth. So, and finally, I'll just give you a quick glimpse of our access policy capabilities, which allows you to configure some of these access control policies and attach them to the applications. And you see that the adaptive access piece over here, which we used, You have the ability to not challenge for multi-factor authentication for a certain period of time, the ability to integrate with external systems. You might already have an investment with a third-party risk provider. You can integrate that as a source, aggregate that information, and build more interesting policy rules down here. With that, I'm going to switch back to the slides. And let me stop sharing. So let me move to the slides and I will kick it off. So what we covered today, what we just saw, I know it was a little bit geeky. You had the IBM Security Verify product. You got a quick glimpse of the product. I know it was really fast. You had there was a whole bunch of things happening in that application where it was making use of the payment API and registering a transaction and so on. So that was happening against the API gateway, and you had the app that you saw. So by the way, this entire app and all of the source code is available, and you can download it from GitHub, and we'll be happy to share that information as well. So in summary, what you've just seen is IBM Security Verify is primed with an out-of-the-box connector that aligns with necessary OpenBanking profiles. You saw the concept of the security profiles and recipes that make it super easy for banks and financial institutions to onboard and enforce and protect their open APIs. You have, we have the ability to secure token management. We are at the cutting edge with the capabilities that we support around token management and token issuance. We provide an out-of-the-box fine-grained authorization engine with the use of for user consent specifically. We support a wide slew of customer authentication capabilities, both for first and second factor. We provide an out-of-the-box financial fraud and threat detection capability on the platform, which you also saw. You saw the adaptive access piece. Now, in terms of certifications and so on, you will see IBM listed practically on every certification on the OpenID.net website and in the certification list, both for Verify Access and for Verify SaaS. So just jump through this. And with that, I'm going to relinquish control to Milan Patel. He's going to take us through a customer case study and then close us off. Thank you.
Thanks, Vivek. There's also one question, and maybe we can answer it in the chat.
Yeah, I'll do that. Okay. Thanks.
So as we conclude, we wanted to leave it off with one customer use case, an international bank, and their use case is basically providing remittance to gamers that enter contests. And the workflow is the following. The gamer, as they win a award, get an email, must create a profile with a bank, with the bank, and then as part of making and creating that profile, the gamer then needs to type in and enter specific information associated with where they want to deposit their money. It could be their own bank. And this is where, as the user registers their account, performs a set of KYC flows related to being able to do due diligence in onboarding and creating an account, provides a way for them to then be a recipient of the payout associated with the flow that they're going through. Now, the proposition that we brought with Verify was related to being able to deliver this solution quickly to market, as well as providing a reduction in risk provided by the ability for Verify to not only perform the authentication and the risk detection, but also having the openness to be able to integrate with the proofing solutions and the KYC solutions brought to integrate related to what the entire workflow requires as part of creating an account. And then the last thing is just the scale. So being able to scale up and scale down related to the transactions that are happening. So this was in collaboration with services and leveraging the IBM Security Verify SaaS product to be able to deliver the value here. And the payment routing is, again, as we described in the early scenarios, being able to link with things like PayPal and Zelle as part of the entire end-to-end scenario. So with that, we appreciate you joining. It's not on this slide, but if you go to ibm.com/verify, I answered in one of the questions of where to get the trial instance. Again, that's ibm.com/verify. You'll be able to get a trial and you'll be able to basically do the scenario that Vivek alluded to and showed related to leveraging Verify to do the open banking, high identity assurance flows, as well as get access to the other capabilities that we have in market, specifically around governance and lifecycle management, which again bleeds into a different set of use cases as part of a converged platform. So with that, we'll spend maybe 5-10 minutes to see if there's any lingering questions. I think we answered all of them. But if there are any more questions, please type them into the chat. And we can spend the next 2 minutes just waiting for those. But if you don't have any questions, thanks for joining. And hopefully you found this session valuable. And we'll be posting the recording and I believe the slides as well once the recording is done.
Yes, and I first and foremost, thank you both for a wonderful presentation. I also just wanted to jump in and get another quick reminder, confirmation to everyone in the audience. Everyone who registered for this event, no matter if you attended or not, you will be emailed the on-demand recording and slides later on today. There will also be a link to connect directly with our experts from the IBM community. So I just wanted to let everyone know, and I see we have a couple questions.
Yep, and I'm answering the questions in the chat. Okay, it looks like the questions have tapered down. You can reach out to Vivek and I as well if you have any other questions as we conclude this webinar. So thank you.
Thank you very much.